Good evening, everyone. Good evening, everyone. Good evening, everyone. Good evening. Check everyone. Audio, video, okay or not? Audio, video, okay or not? Please verify. Please verify audio, video is okay or not. Check once. Check once. If everything is fine, then I can go ahead. If everything is fine, I can go ahead. If everything is fine, I can go ahead. Right? Can I start? Yeah. So I'm executing now. I'm executing. Welcome to exam prep tool. Welcome to exam prep tool RIC course of algorithm for 2025. 2025 purpose algorithm RIC course. Right? So problem number 91. Problem number 91. Can you see this? One program is given. If you observe clearly, one program is given. Right? One program is given. They are asking what is this program time complexity. It's a very nice program. One program is given. They are asking what is the time complexity of this program. Right? What is the time complexity of this program? Right? So this is the problem number 91. This is the problem number 91. This program they are given. What is the time complexity they are asking? Right? Let's start the answer one by one. I think program right is not given the main program. So if you observe clearly, in this problem, if you observe, so start from the f function, right? So let me write here. See this one. What is the time complexity of f of n? Time complexity of f of n is asking. This program time complexity how much? If you start from f, so e written already. See time complexity how much? If you start from f of n. F of n time complexity how much? Let's start now. If you observe clearly, right, if n is equal to 0, right, x is equal to 1, simply return. If n is equal to 0, x is equal to 1, afterwards nothing. Right, lastly there is a return x. So whenever no brackets are there, one statement is belongs to that. See, else, right, else, see this one, else statement. Whenever else is executing, this will execute followed by this. Yeah, this is so else bracket here, right? Else bracket here. So if condition true, x is equal to 1. If condition fail, so x is equal to this one, then g of x is called. Lastly, return x. Then lastly, return x. Right? Now we will see what is the answer of this. If anyone having any doubt in the problem, let me know. He is asking time complexity of this program. He is asking time complexity of this program if you start from f function. If you start from f function, what is the time complexity of this program? Right? In the else if you see, x is equal to f of n minus 1 into 2 g of x. In the else, right? In the else, if you see, there are two statements. Lastly, return x. Right? Now I'm starting executing this program. Everyone observe. Little doubt also there in the problem. Let me know. I want answer from you, right? I want any doubt, small doubt also. Please let me know. Sir, in this problem, I have these doubts, sir. It's one of the nice problem, right? It's one of the nice problem. In this problem, if you have at anywhere doubt, let me know. So I'm starting. I'm starting. Everyone see this? Everyone, if n is equal to 0, x is equal to 1, l, so x is equal to f of n minus 1 means it's a recursive function into 2. Lastly, g of x will be called return x. What is the g of x time complexity? We have to check. Because of he's asking overall time complexity, f function he's asking f function time complexity. Internally, f contains g. Without calculating g, how can you calculate f? So you have to calculate. You have to calculate g also. Let's see one by one. Let's see one by one. What is the g of right? What is the g of x time complexity? Let me check. What is the g of x time complexity? Let me check. Let us assume that. Let us assume. Just I want to ask you one small line. Let us assume, right? What is the g of x time complexity? I will check one time. Whatever you give, g of x time complexity, what? I will check once. Suppose assume that if I give n here, g of x is n, assume. So n will come here. N or m. So whatever you give, it will come here into y. Y is equal to m, y greater than 0, condition true, I will be printed, y is equal to y by 2. Y always divide by 2. Y always divide by 2. Whatever y having, always divide by 2. Whatever y is having, always divide by 2. So, right, those people who are watching, do you have any doubt? Please, can you comment in the comment section? Please comment. I want to know audio video okay or not. I want to check audio video okay or not. I want to check audio video okay or not. Those people who are watching, please comment in the comment section. So that I will get to know everything is fine. So I will get to know everything is fine. Let me know those people who are watching, right? Is everything is okay? Audio video okay? Right? Yeah. Let's go ahead. Let's go ahead. I think everything is fine. So let's go ahead. So right. So g of m time complexity, how much we are checking? If you pass n, I think it will take log n time. Whatever you pass, it will take log n time. Because n, if you pass n, I think always divide by 2, I think log n. Right? So please careful. So now, first of all, for the x, right? What is x here? We will check once. What is x here? We will check once. Everyone listen. So first of all, you have to calculate x. Then x will be given. In terms of x, how much time complexity? Whatever x you give, I think the time complexity of this one is log x. Whatever, if you give n, log n. If you give x, log x. So time complexity of g function is log x. If you give x, what is the x we have to calculate? Let's calculate what is the x. Let's calculate. Forget about g function. Forget about g of x function. So afterwards we will see. First of all, calculate f. So I will try f story. See this one. I will try f story. I think I'm managing here itself. See this one. I'm managing here itself. F of n. See the recursive function, f of n. N is equal to 0? No. N is equal to 0? No. Right? N is equal to 0? No. So, right, then what will come here? It will come here. X is equal to f of n minus 1 into 2. So, every time 2 will be multiplied. If you come one more round, x is equal to f of n minus 2 into 2. I think if you do, see, it became 2, it is a 2 times, so 2 into 2. If you do one more time into 2, so I think it will goes to, in my opinion, this entire story will goes to 2 power n. If you do n time, x became 2 power n. Every time 2 multiplied. First time, right? First time 2 multiplied. So n minus 2, 2 multiplied. N minus 3, 2 multiplied. N minus 4, 2 multiplied. 2 into 2 into 2 into n time. I think x finally become 2 power n. X finally become 2 power n. If you apply, right, what is the g of x? Right? X given log x. Because of x became 2 power n. Log of 2 power n. Right? Base 2, which is nothing but n. So finally, the time complexity of this program is going to be Tn is equal to recursion is recursion. Okay. But remaining time g of x. If x given, log x time, if 2, right, if at all n given log n time, but you are given 2 power n, x will take in the place of x 2 power n, it will become. So it will become log 2 power n base 2, so n. So it's finally, I think, sum of n natural number, and so on, 2 and 1, which will goes to order of n square, It's one of the nice problem. Please let me know if anyone having any doubt. Right? The answer for this problem is, I think, B. B is the answer for this. And I hope everyone is okay. Yeah. And one more thing is, let's see here. Yeah. This problem we are already done in the previous class. Answer is, I think, 8. We are already done this. In the previous class, we done this also. Answer is 4th option, D. This problem also we done. Answer is 1. This problem also we done. Answer is A. We done in the last class. Right? You can see last 2 classes. The answer of this one is B. Right? The answer of this one yesterday only we done. It is a 12. In the last class we done. Yesterday we done. The answer of this one, I think we done this. I think answer is B. Second option. Everyone know this. In the last class we done. If anyone not attended the yesterday's class, please go through it. This also we done. I think we got the answer as, I think, who is the first minimum? First minimum is going to be F2. Next minimum is going to be F3. Next is going to be F1. I think D is the answer. We are already done yesterday. Those people who are not attended yesterday's class, yeah, please go through it. Now today's class, problem number 230. Today's class, problem number 230. But I want to remind everyone, as part of the RIC course, every subject we are going to solve for every subject 300 approximately 300 questions we are going to solve. As part of RIC, for every subject, we are going to solve 300 questions approximately. Very quality questions. If you attend these all total RIC course, you are going to get approximately 70 marks. Let's start. The today's session. Right? So this problem, let's start. Problem number 230. Start. What is saying? The given diagram shows the flow chart for a recursive function A of n. The given diagram shows the flow chart for a recursive function A of n. Assume that all statements except for the recursive call have order of 1 time complexity. All statements except for the recursive call have time complexity order of 1. If the worst case time complexity of this function is n power alpha, then the least possible value of alpha is. Then what is the alpha? And one more thing is, worst case time complexity of this function is n power alpha. Then find out what is alpha value. Accurate up to 2 decimal positions of alpha. Let's check. Because of he is asking worst case, you have to see that path. Because of he is asking worst case, you have to see that path where worst will come. Worst case you want, and you have to see that path where worst can come. You have to see that path where worst. I think it is starting from main program. You can go left also, right also. If you go left side, only one function call. So I think if you see right side, so many function calls are there. We have to take that path where maximum time will come. So maximum function call, maximum time. So I think here if you observe clearly, followed by this. Now again here condition, there are 2 choices. You may go down, you may go to right. If you go right, problem is over. I think time complexity will be less. If you go down, because I'm able to see more function calls, I will go here. because he's asking worst case. If best case, here I will go left. If best case, here I will go left. Because if he's asking worst case, I will go like this. Now again here two choices. You may go down, you may go right. If you go right, again little more less time. But if you go down, you will have more time. So I will go down because I want more time because I want worst case. Again here two choices. You may go left, you may go right. If you go right, maybe less time. If you go left, one more function call. I think further no other choices. So this is the path. This path will leads to best answer. This path will leads to best answer. Can you see how many function calls? 1, 2, 3, 4, 5. 5 function calls. So if you see the reference relation for this, time complexity of this recursive program Tn is equal to 5Tn by 2. But see this one, he said that every statement will take a constant time complexity except recursive people. Means other people are constant. Means C. So it will goes to 5Tn by 2 plus C. Right? Plus C. Now, I think this one you can solve using master theorem. So n power log A base B find out. Right? So n power log 5 base 2. F of n also find out. C. So you know the master theorem. If f of n is big O of n power log A base B, f of n is C, right? Big O of n power log 5 base 2. Yeah, yes, it is true. Master theorem is applicable. I think master theorem first case. If f of n is big O of n power log A base B, it is true. So answer is this only. Master theorem first case. So answer is n power log 5 base 2. So is already mentioned time complexity of this program is n power alpha. Alpha is this. Alpha is this. So alpha value is equal to log 5 base 2. Right? Whatever it is. Someone is saying that 2.5 something like this. Whatever it is, calculate in the calculator properly. Calculate in the calculator properly. I hope everyone is fine with this problem. So many times, if at all they will ask you best case, if they ask you best case, right at the starting itself, go left side. Then time complexity. If the question is best case, time complexity Tn is equal to Tn by 2. Go left side constant. So which will goes to answer is log n base 2. Answer is log n base 2. If the best case, answer is log n base 2. Right? If at all they are asking best case of this problem, answer is log n base 2. Worst case n power log 5 base 2. N power log 5 base 2. Right? I hope everyone find this is a problem number 230. It's a problem number 230. We are going to solve approximately 300 questions. 300 questions of right algorithm. Every subject, each subject 300 questions will solve. Each subject 300 questions we are going to solve. Right? If you solve only these 300 questions of each subject, approximately you will get right. Question paper contain indirectly, directly from these 300 questions only of each subject. Indirectly, directly. Approximately you are going to get 70 marks. 70 marks, right? Plus you are going to get. 70 marks plus you are going to get. Right? Please be comfortable with all these things. Let's go to next problem. Can you see this one? Problem number 221. Problem number 221. Problem number 221. Try now. What is the answer for this? Problem number 221. Yeah, what is the answer for this? Check everyone, check everyone. What is the answer for this? Anyone can give answer for this? A min heap having 1024 distinct elements. Remember, min heap is having 1024 distinct elements, with the keys ranging from 0 to 1023. Keys ranging from 0 to 1023. Totally 1024 people. They given the elements range also, and one more thing is distinct. No one repeating. So keys range from minimum 0, maximum 1023. Of course, no one is repeated. Is stored in the array of 1024 indices. Okay. So 1024 people, distinct people are there in the form of a min heap. They are stored in the indexes, right? 0 to 1023, of course. The maximum difference between the keys of all elements that can possibly be stored at n by 2 the index of the array. Yeah. What an excellent problem. It is one of the excellent problem. If you can get this problem in the heap sort, most of the problem you can solve. If you can solve this problem in the heap sort, most of the problem you can solve. Let's start here. Let's start. I'm going to give answer. Let's start this. So let's discuss the diagram here. Carefully, everyone. Careful, everyone. Yeah, let's see this. It is the index 0, index 0, index 1, index 2, index 3, index 4, index 5, index 6. So if you observe clearly, see this one. First level, see. It is the 0th level maybe. First level, first index, how much? First level, first index, how much? Yeah, if you want, you can go for, it's a level 1 also. Let's see this one. Level 1. Whatever way you want, you can think, no problem. Level 3. Right? Level 1, level 2, level 3. So, level 1, first index. See this one. Level 1, first index, if you see, level 1, first index, if you see, how much? 0th place, first place, second place. Level 1, first index. 2 power. It's a level 2, no? It's a level 2. Level 2, first index. See this one. Level 2, first index is, because of level 2, 2 minus 1 you do. Means 2 power 1 minus 1. Level 2, first index is this one, 1. Next one, level 3, first index. Because of level 3, 2 power 3, in the power right minus 1, below also right minus 1. It became 2 square, 4 minus 1, 3. In the similar way, level 4, it is a level 4. It is a level 4. Level 4 first index is, 2 power 4 minus 1 over minus 1 below. 2 cube is 8 minus 1, 7. It is 7. So if you want, you can check the next one. It is a level 5. Level 5 first index. Level 5 first person index is 2 power 5 minus 1 becomes 2 power 4, 16 minus 1, 15. Right? Check properly. Whatever I done is right or wrong, please verify. Because of you are really comfortable, can you see this? Can you see this one? Level 5, this is the story. What about level 8? If at all level is 8, isn't that the level 8? If at all it is a level 8, let me check. So it is a 2 power 8 minus 1, 2 power 7, 128 minus 1, 127. Right? So level 8 also okay. Let's go to level 9. This one, level 9. level 10, level 11. If really required, we will see that. Right? Let's see this one. This is going to be level 8. Previously level 8, right? It's a level 9. Level 9. So 2 power 9 minus 1. Upper also, niche also. 2 power 8 is 256 minus 1, 255. Because we are looking for n by 2. We are looking for n by 2 within few minutes you will get. It is a level 10. It's going to be 2 power 10 minus 1 minus 1. 2 power 9, 512 minus 1, 511. It is a 511. It's a 511. It is a 511. If you want, you can check. It is a 512. It is a 512 index. And if you observe clearly problem, right? See this one. Total 1024 people are there. Total 1024 people. In that half, 1024 by 2. 512. Is asking the maximum difference between the keys of all the elements that can possibly store at the n by 2 index of the, right, n by 2 means I think 1024 by 2 means 512 index. At the 512 index, what the maximum element can store, what the minimum element can store. At the 512 index, what the maximum element can store, what the minimum element can store. And one more important thing is remember with the right, see this one. I will write this also. I will write this also. Can you see this one? With the two levels, the maximum nodes you can store is 2 square minus 1. With the three levels, the maximum nodes you can store is 2 cube minus 1. With the 10 levels, right? It is a 10th level. With the 10th level, the maximum nodes you can store is 2 power 10 minus 1, which is going to be 1024, 1023, but elements are 1024. So one more level required. It is the 11th level also there. So this problem contains totally level 11. It is a level 10. So this problem actually contains 11 levels. This problem actually contains 11 levels. Remember everyone. This problem actually contains 11 levels. He is talking about this position. He is talking about this position. He is talking about this position. This problem actually contains 11 levels. He is really talking about this element. At this place, what is the maximum I can store? What is the minimum I can store? I think everyone know in our array elements are 0, 1, 2, 3, and so on. 10, 23 is the last element. In our array 0 to 10, 23 elements are there. The maximum you can store is here 10, 23 you can store. Because after this in this level, maybe no one will come. Here only one element is there. Right? So here if you want, you can verify properly. The maximum you can store is 1023. Some people are asking, sir, what is the minimum? Because of the mini heap, root will be minimum. So see this one. 0 you can store here, 1 you can store here, 2 you can store, 3 you can store. Right? 4th level 3, 5th level 4, and so on and so on. 8th level 7, and so on. 9th level 9. See, 8th level 7, 9th level 8, 8. So 10th level 9. You can store 9 here. So minimum 9. Minimum is 9 you can store. Maximum is 1023 you can store. Please check properly. At this place, minimum maximum 1023, minimum 9 you can store. At this index, maximum I can store 1023. Minimum is 9. Please verify. Remaining people I can adjust. Whatever elements are remaining, I can adjust. If anyone having small doubt, take one small example and check. If you have small doubt, take small example and check. If you think it is creating some trouble to you, so take something like right. Take something like 8 elements. Take something like 8 elements. You can easily get 8 elements means what? 8 elements. I think 4 levels. See this one? 8 elements. If you have little doubt also, you can take 8 elements and you can try. See this one. 8 elements. 0, 1, 2, 3, 4, 5, 6, 7. Right? 0 to 7. 8 people. 0 to 7. 8 people. So let me try this. Let me try. 0 to 7, 8 people. So now if you want, you can check. This index is talking. Everyone now, 8 people. 8 by 2 means fourth person. 8 by 2 means fourth person. See, 0 person, first person, second person, third person, fourth person. Is the fourth person. Here, what is the maximum I can keep? Here, what is the minimum I can keep? Maximum what I can keep, minimum what I can keep. See the maximum. See the maximum. See the maximum. Here I can keep 7. Check. Remaining people I will adjust. Remaining people I will adjust. There is no problem at all. Right? So remaining people I can adjust. So here maximum I can keep 7. Minimum I can keep. Minimum I can keep. See, so 0, 1, 0, 1. I think here 0, 1. Here 2 I can keep. Remaining people I will adjust. 0, 1, 2. 0, 1, 2. Because of it is the third level 2. Because of it is the 10th level. Right? See this one. Because of it is the 10th level 9. See, third level is 2 came. Third level 2 came. Because of it is the 10th level 9 came. 10th level 9. Third level 2. So minimum 2. Maximum 7. What is that 7? Maximum person. So minimum person 2. So the difference is 5. So the difference is 5. So same thing here. What is the difference here? 1023 minus 9. I think 1014. Answer is 1014. Right? Answer is 1024. Answer is 1024. It's one of the excellent problem. It is one of the excellent problem. Answer is 1020. Right? 1024. Sorry, 1023 minus 9, which is going to be 1014. Answer is 1014. Answer is 1014. A min heap is having 1024 distinct elements with the keys ranging from 0 to 1023 is stored in an array of indices 1024. The maximum difference between the keys of all elements that can possibly stored at n by 2 index of the array is. Right? 1024, 1014 is the answer for this. 1014 is the answer for this. So this problem I think everyone done. Yeah, this is the next problem. I hope everyone got it. I hope everyone got it. Let me know if anyone having any doubt. Let me know if anyone having any doubt. So let me say this one. If you are serious about GATE 2025, if you are serious about GATE 2025, if you are serious, you have 5 months time. You have 5 months time. If you are serious about GATE 2025, you have 5 months time. This RIC course is designed for these 5 months only. It is a practice course. It is a practice course. RIC course designed for you only. It's a practice course. 5 months time is there. RIC is for practice. Right? Each subject 300 questions. Like that, 13 subjects. Approximately 3,000 to 4,000 questions we are going to solve. If you solve all these things, minimum you are going to get 70 marks. 70 plus marks you will get. Minimum 70 plus marks you are going to get. Minimum 70 plus marks you are going to get. 5 months time there, RIC practice course, this is the practice course, right? And one more thing is approximately, right, flat 60% discount is going on. Flat 60% discount going on, please utilize it. Flat 60% discount is going on, please utilize this. Please utilize this. Yeah, let's come to next problem. In an adjacency list representation of undirected simple graph G is equal to V comma E, each edge UV has two adjacency list entries, right? V in the adjacency list of U and U in the adjacency list of V. These are called twins of each other. A twin pointer is a pointer from an adjacency list entry to its two twin. If E is equal to M, V is equal to N, and the memory is not a constraint, what is the time complexity of the most efficient algorithm to set the twin pointer in each entry in each adjacency list? Yeah, this is the given problem. Yeah, so can you try this problem? It's a problem number 57. It's a problem number 57. So like this, we have approximately 300 problems. We have 300 problems. 300 problems we are going to explain. We have 300 problems. These are going to be really useful to you. These are going to be really useful to you. My request to everyone is, right, you can join the RIC course. It is going to be really useful. It is going to be really useful, right? So all the things one time you see. Whatever you are doing, do. If you are doing something, you can do. I don't have any problem. But do this also. It will really enhance. It will really enhance your abilities. It will really enhance your abilities. Yeah, so 300 quality questions. See, at this point of time, Pankaj, at this point of time, right, you need practice only. See, we will explain details. See, one question we are explaining almost like half an hour. I explained this problem, half an hour I explained. So, we will explain all the things which are needed for that. Some concept also, not only giving answer, some concept also. Concept also we explained. See, this problem we explained half an hour. Right, in the rank improvement course, we are going to explain every problem and surround necessary things which are required. Whatever necessary required surrounding that, we are going to explain all. Right, this is the practice course. This is not a theory course. This is the practice course. If you completed the subject, this is going to be really useful to you. If you completed the subject, this is going to be really useful to you. If you are not completed, some people are asking, sir, we are not completed syllabus. So complete and join. Complete and join the RIC course. First complete. But whatever subjects completed, let us assume that these are completed subjects. These are completed subjects. Not completed is this. These are completed subjects. These are not completed. So completed subjects do RIC. Every day few problems. Every day 10 problems you solve. Completed subjects, every day 10 problems solve. Completed subjects, every day 10 problems from RIC. Because RIC questions are having so lot of standard. RIC problems are having lot of standard. Mostly you will do mistakes. RIC problems, mostly you will do mistakes. So the suggestion is, right, take completed subjects, every day do 10 problems. If possible, do more also. Not completed, then complete the syllabus. So every day you are working 10 hours per gate, 7 hours spent here, 3 hours spent here. Every day you are keeping 10 hours per gate, 7 hours keep here, 3 hours keep here. Plan like this. Plan like this. Right? Fine. So this problem, can you try this? In an adjacency list representation of undirected simple graph, each edge UV has two adjacency list entries. V in the adjacency list of U and U in the adjacency list of V. These are called twins of each other. A twin pointer is a pointer from an adjacency list entry to its twin. If E is equal to M, V is equal to N, right? And the memory is not a constraint. What is the time complexity of the most efficient algorithm to set the twin pointer in each entry of adjacency list? Yeah. Can anyone guess what may be the answer? What may be the problem? Remember, it's adjacency list too. He's not asking matrix. Matrix or list. Can you check here? He's asking list or matrix check. What is the time complexity of the most efficient algorithm, right? To set the twin pointer in each entry in each adjacency list. So remember, right? You can represent the graph in two ways. Matrix also, list also. You can represent the graph in two ways. Matrix also, list also. Adjacency matrix, adjacency list. So this problem is related to list. This problem related to list. Let me try this. Let me try. There is and one more thing is undirected graph. Let me write the major points. This is related to undirected graph. It is related to undirected graph. And one more thing is it's related to adjacency list. Write the keywords first. Undirected graph given one and adjacency list. These are the two things, right? Now let's check one by one. What you want to say is, see this one. What you want to say is, if there is a graph, see this one. Let me write adjacency list. Yeah, 4. 4 people assume. Here assume that A, here assume that B, here assume that C, here assume that D. So A adjacent is maybe B. Right? A adjacent is B, and C also, and D also. So, but one thing I want to ask you, if A adjacent is B, because of this undirected graph, B adjacent also A. Because of this undirected graph, if A adjacent is B, B adjacent also A. If A adjacent is C, right, C adjacent also A. If A adjacent is D, D adjacent also A, because it's undirected graph. Right, next one. B adjacent is A also. Let us assume B adjacent is D also. So if the B adjacent is D, D adjacent also B. Suppose assume that, suppose C adjacent is A, C adjacent is, assume that C adjacent is B also, assume. C adjacent is, assume that D also. If C adjacent is B, B adjacent also C. If the C adjacent is D, D adjacent also B. It's almost like complete graph. It is almost like complete graph. So if you want, you can remove few people. Sir, no, sir, I want to take some other graph. Then you can delete few people. You can delete few people. Suppose B adjacent is C. Then C adjacent also B. So you can delete some people. Let us assume. So C adjacent is D, right? D adjacent also C, right? I think this one you can delete. One person you can delete. If the C adjacent is D, D adjacent also C. I deleted one person. If you want to delete someone, you can delete. I don't have any problem, right? So this is the graph. This is the graph. There is a one undirected graph which is shown in the form of a adjacency list. Undirected graph, adjacency list. So if anyone says, sir, I want to see the graph, how graph look like? Sir, how graph will look like? You can see this, A, B, C, D. So A adjacent is B also, A adjacent is C also, A adjacent D also. Go to the B now. B adjacent A, B adjacent is D also. B adjacent to C also. If you go to the C, C adjacent is A, C adjacent B also. If you go to the D, D adjacent A also, B also. Yeah, this is the given graph, which is shown in the form of a adjacency list. Yeah, I think everything is fine. Now listen, everything is fine. Remember everyone, if at all two people are adjacent in the undirected graph, In the undirected graph, two people are adjacent. In the undirected graph, if two people are adjacent, in the A adjacency list, B will be there. In the B adjacency list also, A will be there. So these are called twins. If at all two people are adjacent in the given graph, then suppose A and B are adjacent. In the given graph, two people are adjacent, A and B. Then A adjacency list B will be there. B adjacency list also A will be there. These are called twins of each other according to the given problem. According to the given problem, two people are said to be twins of each other. If two people are adjacent, then A adjacency list B will be there, B adjacency list A will be there. Those are called twins of each other. Now, I think because of he's talking something about pointer and all, so let me write that also. Every node having some address. Assume it is 1K, assume it is 2K, assume it is 3K. Some address. Every node having some address. Right? So, B right, in the A adjacency list, B person is 1K, right? C is 2K, it is a 3K. Let's see this. It is a 4K, it is a 5K, it is a 6K. It is a 7K. Every node, when you are creating, maybe using malloc you are creating, maybe using new you are creating, in the heap area they created, every person having some address. It is a 9K, it is a 10K. Now see the answer. Now see, everyone listen. Now everyone listen. A adjacent B means in the A list B will be there, in the B list also A will be there. So then right, remember to this B, this A is called twin. If A, B is adjacent, in the undirected graph, for the A, B is adjacent, then A adjacency list B will be there, B adjacency list also A will be there. This B and A is called twins of each other because between both of them it's there. Now he is asking twin pointer. If you observe clearly, B twin is A. So B address is 1K, B address is 1K, A address is 4K. You have to arrange a twin pointer. Means what I mean to say is, create one more part in the given node. Actually, till now, node contain only two parts. Let's make three parts. So now B will point to its twin. Means this is 4K. Then A also point to its twin. This is 1K. So if anyone having small doubt, this is B, this is A, address of this one is 1K, address of this one is 4K. They both are twins of each other. So because of their twins of each other, E will point to here, E will point to here. So it contain 4K. It contain 1K. You have to set the in the given adjacency list between each twin, you have to keep a right twin pointer. In the given input there is no twin pointer, but you have to keep the twin pointer. In the given input there is no twin pointer. He said the definition of twin pointer, you have to change the adjacency list in such a way that every person should point to its twin. You have to set the twin pointer. You have to set the twin pointer in each node. So how much time it will take? Let's see everyone. Listen, I am doing a work. Everyone listen. It's a very, very interesting answer. This trick, if you can follow, problem is solved. See this one. Everyone have to listen. Everyone have to listen. How to create twin pointer. So this is the graph. Let me take the graph. I have to set the twin pointer. How to set the twin pointer? I am explaining. This is the graph. This is the graph. See how I am keeping the twin pointer. Everyone listen. How I am keeping the twin pointer. See this one. A first. Careful everyone. See this one. As of now, visiting is A. As of now, visited array. Right? A will be there. A is visiting. As of now, not visiting. Now, after completion of this, it will be visit. Initially, visited array is nothing. Now, I am visiting A. Now, see what happened. A adjacent is B. Create one node here. Everyone listen. A adjacent is B. A adjacent is B. Create one node for B first. A adjacent is B. See the graph and top. A adjacent is B. So in the A adjacency list, create one node B. Address is assumed 1K. And one more thing what you have to do is, because A adjacent person is B means A twin is B, B twin also A. Then what you do is, in the A adjacency list you are creating B. In the B adjacency list also you create A. At a time create both the twins. You are doing A work. You are doing A work. A adjacency list is B. You got to know A and B are twins to each other. So what you do is, in the A create B, in the B also create A. Yes, I created. Address is 4K. Create at a time both the people. After creating, link them. Here you keep 4K, you will come here. Here you keep 1K, you will go here. So create twins at a time. So A goes to B. See this one. A goes to B completed. Now A goes to C also there. So in the A adjacency list, right, add C first. In the A adjacency list, add C. Because of A twin is C, then C twin also A. So in the C also create A. At a time create twins. At a time create. This is assumed that 2K. This is assumed that 3K. At a time create, right? So it's going to be A. Link them. So this is going to be, right? This is going to be 3K. This is going to be 2K. At a time create. Next one. A adjacent is C also done. Next one. A adjacent D also. A adjacent D also. In the A, create D first. Right? In the A, create D. In the D also create A. In the D also create A. At a time create both. Using malloc create both the people. So this is assumed that, I think 1, 2, 3, 4 over, it's a 5K, it's a 6K. In the 6K keep 5K. In the 5K keep 6K. It is a D, it is a A. Then these two will point to each other. So now A adjacent all completed. That means widget of A successfully over. Right? So A adjacent people all you done. So that means V is equal to A. So previously V is pi. Now V is A. Now A completed. Now in the given graph A completed. Let's go to B. Now listen everyone. Let's go to B. Yeah, start. So B goes to A. Right? Already A is done. B goes to A. See this one. B goes to A. Already A done. So no need to do anything of old people. B goes to A means A person is previous one. In the widgeted array already there, don't do. Next one. B goes to D also. See, in the widgeted array, D not there. So because of not there, create. Because of not there, create. See, I am creating. In the widgeted area, if at all, B adjacent is D also. In the widgeted area, D not there. So now widget. So D create. See this one. B adjacent to D means D adjacent also B. Create both. Both the twins create at a time. It is a 7K, it is a 8K. Create at a time. That is the logic. Then link them. So this is going to be D. This is going to be D. So I think B adjacent A already done. B adjacent is a D. Right? Now only you done. B adjacent C also. C also not done. So B adjacent C also. Create C. B adjacent C means C adjacent also B. Create at a time. It is a 9K. It is a 10K. Link them. It is C. It is a C. It is a A. Link them. Now B adjacent is all covered. B adjacent is A already done, C already done, D already done. That means B also completed. So B also done. Now like that, let's go to the C. Let's go to the C now. C adjacent is A already done. C adjacent is B already done. So nothing else. No need to do anything. Let's go to the D. D adjacent is A already done. Already C I have to add. D adjacent is A already done. D adjacent is B already done. So D also done. All are done. So what I mean to say is you have to scan total adjacency list one time you have to scan. At a time create both the twins, link them. At a time create both the twins, link them. You have to visit total story one time. Total adjacency list visit one time. Total adjacency list visit one time. You have to visit one time. So here M vertices are there, N edges are there, N edges are there. You have to visit one time. So time complexity of this problem is order of M plus N. So you have to go row by row. Do this, do this, do this, do this. One scanning required. Time complexity order of M plus N. That's the reason I want to say to you, you cannot do everything in the last month. That's the reason I am saying to everyone, you cannot do everything in the last month. It is impossible. Please start from now onwards. My request to everyone, please start from now onwards. Please start from now onward. Don't do everything in the last month. Please do now. Please start now. Please start now. It is a problem number. It is a problem number. See, it is a problem number 57. Previous problem 221. This problem number is, this problem 230. This problem number 229. Randomly I am explaining. 300 problems I am going to explain. So my request is, if you are serious, you can happily join RIC course. GATE 2025. If you are serious about GATE 2025, these 5 months you have to utilize properly. So RIC course is a practice course. 300 problems I am going to explain for each subject, like 13 subjects. Totally, approximately 3,000 to 4,000 questions I will explain. If you study all of them properly, mostly you are going to get 70 plus marks. So every day you have to study from now onwards. Every day you have to study from now onward. Total 10 hours you are studying. 3 hours study. 3 hours study, right? Rank improvement course, right? 3 hours study rank improvement course, right? 7 hours study new subjects. If you do that, you are going to get a very nice rank. So test series contain all the tests, na? Test series contain all the tests, right? Fine. So I think from the last 3 days, approximately I done 30 problems. Approximately I done. Last 3 days, approximately I done 30 problems, right? So 30 problems I done approximately. So I hope it is going to be useful to you, right? Thank you so much. And one more thing is, there is a flat 60% discount going on. It is going to be close. 60% discount is going on. It is going to close very soon. So please utilize it. Please utilize flat 60% discount. Flat 60% discount is going on. It is going to be closed soon. Afterwards, you don't cry. Afterwards, you don't cry. It is going to be closed very soon. Use the code EPT 595 capital ARJ. EPT 595 ARJ. You can use it. Yeah, everything there, yaar. Are Abhiraz, everything there, man. Everything there, man. Everything there. The only thing is you have to utilize it. Make it fast. Make it fast. Yeah. See you in the next class. If anyone having any small doubt also, see. If you find any difficult problem, please let us know. If you find out any difficult problem, please let us know. This is the WhatsApp number. Any difficult problem, if you find out, please let us know. We will do every day your doubt solving also. For each subject, every day we will do your doubt solving also. Right? Difficult problem is there. Please WhatsApp us. Please join the EPT Telegram group. You can post there. EPT Telegram group, you can join and you can post there. We are going to solve all your doubts. Right. So thank you so much. See you in the next class. Thank you. Thanks everyone. Thanks everyone. Thank you so much. Thank you.